Hey guys, in this section 4.5, we're going to be graphing trig functions. Specifically, we're going to be graphing the sine and cosine curves. And we're also going to use algebra to transform these on the coordinate grid. Recall from yesterday with our activity with spaghetti that we learned where the 6 trig functions were located on a unit circle. Knowing this, we can use these to graph our sine and cosine curves. If you go to this link, there's a simulation that you can look through that actually graphs your sine and cosine curves for you. What you'll notice is for the cosine curve that the line goes from the y-axis all the way to the point. As you move the point across, the angle will get larger, but you'll notice that that arrow is actually getting smaller. Down at the bottom, you'll also notice that your cosine curve is decreasing as well. As you get closer and closer to the y-axis, it gets smaller and smaller until it becomes 0. Then, once you go into the second quadrant, you'll notice the arrow is pointing the opposite direction. As a result, this is going to go into the negative portion of the xy grid, and this is why you see cosine going into the negatives. Then as you get closer and closer to the x-axis on the left side in the second quadrant, you'll notice your value gets bigger and bigger again. As you go all the way around, those values get repeated. The graph starts all over again. You can do the exact same thing with the sine curve as well, and also the tangent curve. Once we know the general shape of the sine and cosine curve, we'll take the key points, there's 5 of them, to graph using our transformations. These are going to be your relative max, your relative min, and also your x and y intercepts. Using these 5 points, we can transform any graph for the sine and cosine curve using our transformations we learned from Algebra 2. Please recall for your transformations from Algebra 2, we learned about what A will do, B will do, C, and D. It works the same way for your sine and cosine curves as well. Remember, when A is negative, you'll have a reflection of the graph over the x-axis, and when B is negative, you'll have a reflection over the y-axis. Also remember that your A is going to be in charge of your vertical stretches and vertical compressions. When A is bigger than 1, you'll have a vertical stretch, and when A is between 0 and 1, you'll have a vertical compression. For your horizontal stretches and compressions, this will be letter B. When B is bigger than 1, you're going to have a horizontal compression, and when B is between 0 and 1, you'll have a horizontal stretch. Now D is going to either move your graph up or down. If D is positive, we'll move it up, and D is negative, you'll move it down. Finally, C is going to determine if it moves left or right. Please keep in mind that B has to first be factored out before you can determine your C. Once you factor out your B, C will be left inside the parentheses after the x minus symbol. If C is negative, your graph will move left. If C is positive, your graph will move right. So now that we've reviewed our transformations from Algebra 2 and included it in our trig graphs for sine and cosine, let's do some examples together.